My name is Juan Berciaga, and I'm doing a screencast on three standards: excitation, reflection, and tube standing waves. I would like to first start with excitation and talk about the fipple. Right here we have a flute that is open. So when you breathe a pulse, the fipple knives the air, separated into two. One goes up and one goes down. While when that air goes down, it acts as a push. All the air molecules act as they flow into one another and communicating a sort of an idea. For example, here on the CDF player, we have an open and a push. In slow motion, all these air molecules push one another and creating this wavelength. As when the air molecules reaches towards the end, the air molecules still go out, but then acts as a reflection, which act as a pull. So for example, having a push-pull on an open, you first see that the molecules are being pushed, so the idea is being shoved towards one another and reflected back. If you would like to calculate the time it takes from where it starts and towards the end, you would have to measure the period of time where it takes to go from one end to the other, which you can calculate as period equals distance over speed, which is t equals 2L over v. We can formulate that put that in our frequency, which is 1 over time, period. We could equal that to 1 over 2L. If we were doing it with a open-closed one, we would just have a push and pull. For example, if we add the wall into our CDF file, go back in time, the molecules still are knocked into one another and reflected back, but the thing that's different between open and open close is that the air molecules at the end encounter twice as much force and are shoved back, so the air molecules outside of the wall are not being pushed. Trying to calculate it in tube standing waves. Open, we know that open is A for antinode, and close is, I would say, N for node. We can measure antinode to node as a fourth of lambda. So ANA is 1/4 plus 1/4, so you get half, so L equals 1 lambda over 2. So on and so forth. With open close, it's different. Open A, N closed, we can calculate that by AN, which is a fourth, so it'll be 1 lambda over 4. If we plot both frequencies, for example the flute and clarinet, we can see in Audacity that when the flute is being played, you get the evens. And then, for example, when the clarinet is played, you get the odds, so they would skip one another, sort of say. That's it.
Done?
I'm done.
Oh. I didn't know if you were like just telling me you were done or what the deal is.
No, I just recorded it. No, I'm just listen to it.